My name is Tushar Anand, and on behalf of Palin Analytics, I would like to welcome you all to this session today. And today we are going to be talking about what data science is, and we are going to be talking about very broad sense of how exactly, what exactly is data science, and what exactly is even the need. What are the problems that we are facing in the real world that we are trying to solve using data science? What all companies are kind of working in this particular field, and what kind of projects can you expect, what the salary expectations and all that. And in the very end, we will be talking about action plan as to now that you understand what data science is, how exactly are you going to start learning data science. So we'll be talking about these things broadly. So all right, so let's begin now. So we'll first of all, before me going into machine learning and all those things, first of all, I would like to very much explain to you what data science is. Um, uh, since this is an online session, I do not know a lot of you, and I do not know what backgrounds you're coming from. Are you familiar with programming? Are you coming from completely non-technical background? If you have the background of mathematics and statistics or not. So my point is, from whatever field you might be coming from, there must be some kind of reason that you are here today with me. You must have heard of data science, maybe from your friends, or maybe from the company that you're working with, or somewhere. So a lot of people might have a lot of different definitions about what data science is. And first of all, I would like to clarify this once and for all, so that we are all on the same page. So can anyone take an educated guess? Can you quickly write in the chat box, what do you think data science is? You must have heard of data science, right? From your friends or from the internet or somewhere. What do you think data science is? Can okay. So my turn. So when you talk about data science, data science is an art of making data-driven decisions. I'll repeat. Data science is an art of making data-driven decisions. What is the meaning of that? What is the meaning of that? What is the meaning of decisions, and why should my decisions be data-driven? So first of all, what are decisions? Decisions are the choices that we make at every point of time. I think someone was sharing their video. Someone was like walking. I think Shubham is the one who is currently attending this webinar while on his way somewhere. My point is, every single choice that you take, okay, the way you are walking, the way you take your steps, the way, I think you get my point. Every choices that you make, it might be while you are driving, it might be while you are studying, it might be your future planning or whatever. Every decision, every options that you have, every choices that you take out of n number of options that you could do, you decide that I have to overtake this car, or I have to walk to this place, or I have to do this thing, I have to do this much. You get my point? So every choices that you make are nothing but your decisions. And why do we want our decisions to be data driven? What is the advantage that data driven decisions are going to bring into the picture? I do not want my decisions to be driven by my emotions. Just because mera mood acha hai, I do not want to do something, right? There should be some logical reasoning behind me doing something, so that my output that I'm getting in return is like, and a very optimal result is what I'm getting. So my point is, data science is nothing but an art of making data-driven decisions. The decisions that we have been taking, we did not have data science, 10 years back. No. I mean, not a lot of people had even heard of data science. So the industry was not working then. Companies were not operating. They were not profitable. You were not living your life very happily when data science was not available with you. So what exactly is data science giving you? You are still taking decisions. You are still making choices. You are still doing n number of things. Data science only is going to help you take better decisions, so that the output that you get from those choices that you make, the output that you get should be the maximum output that you can achieve, the maximum profitability that you could achieve. Some examples could be like that. So I hope you understand what data science is in a very broad sense. And when people say analytics, so data science, in my opinion, if you if you go back to the discussion around English grammar, jahan pe ki, we used to have parts of speech. So say, for example, if data science is a noun, the implementation of data science is nothing but analytics. All right. So the implementation part of it would be considered as something that people say analytics. So this is very broadly about data science. And let's now try to understand these different terminologies that people kind of uh, have might have heard of. Wait, wait. Let me just go back to the very beginning slide. Yeah. So data science. So what is data science all about? And can I minimize this pen? Yeah, can I also minimize this pen? Yeah. So I hope you understand what data science is. It is an art of making data-driven decisions. And now, what I'll attempt to do is I'll try to kind of clear these things as to what is the meaning of machine learning, what is the meaning of data wrangling, what is the meaning of data mining, what is artificial intelligence, what is machine learning, what is neural network, what is convolutional neural network, what is recurrent um, what is reinforcement learning, what is recommendation engine, what is natural language processing. So let's talk about these things now. um, Artificial intelligence, what do you think AI is? A lot of people talk about AI, artificial intelligence. What do you think? So someone has written machines behaving like humans. Okay, what exactly did you mean by that? So first of all, let's try to understand intelligence, and then we'll attempt to understand what exactly is artificial intelligence, right? So Danesh is still having problems connecting to the audio. Can learn from past experience. All right. So intelligence, the ability of an entity. So in our case, entities are us, human beings. So the ability of an entity to decide for themselves what exactly has to be, what steps I have to take. Okay. So that particular thing is intelligence. And artificial intelligence, no, Sanket, I would not agree to you saying giving instructions to the machine, because right, you will very very shortly you will understand that now we do not have any instruction to give to the machine. We want the machine to learn by itself. Rather than us giving instructions to the machine is going to learn by itself, and that is how it will be called machine learning. Okay, so it's not completely. I will not completely agree to this statement saying that give instructions to the machine. By the way, so my point is, intelligence is the ability of any entity to decide for themselves what they need to do based upon whatever situations they are in. All right. So a machine or a program that is able to do that would be called an artificially intelligent machine. If you have heard of this movie called The Imitation Game, you might have seen this guy named Alan Turing that devises a machine. And from Alan Turing only we have this test called Turing test. If you have heard of this word, Turing test, the test for artificial intelligence. So Turing test says that, say for example, there are two people. Wait. So Turing test says that, say for example, there are three people. For example, one of them is Aditya. Okay. And there are two other people that Aditya is not able to see. Make sense? There are three people. One of them is Aditya. And in front of Aditya, there are two more people, person A and person B. But Aditya is not able to see person A and person B. He can simply talk to these guys. Okay. Now, one of them, these persons A and B, which Aditya is not able to see, let's assume that one of them is a machine. If Aditya, just by talking, without looking at the machine itself, without looking, because if you see a computer talking to you, you will of course understand that it is a AI device. But without looking at the program itself, if by talking or if by interacting, if Aditya was not able to decipher whether he was talking to a real person or a machine, then in that scenario we will say that the machine has passed the Turing test. That means the machine is going to be called an artificially intelligent program now, if it passes the Turing test. So if you have heard of these things. So artificial intelligence and data science, let's talk about these two things now and how exactly are they related. So once again, a lot of different people will define this in a lot of different ways. You will find a lot of different websites, trying to portray the picture between how exactly is data science and artificial intelligence related. But in my opinion, as far as I understand, see, artificial intelligence is predominantly a field of research where we are concerned with making such kind of machines that can interact, that can make decisions on their own in any situation that you put them in. right now in the current industry, in the current world that we are living in, we are still very far away from attaining those kind of machines which are going to kind of behave themselves, you know take decisions in any scenario that you put them into. We still do not have those kind of robots or those kind of things that we envision in movies and novels. Right now, what we have very narrow AI. So there are three different types of AIs. The first one is called narrow AI, the second one is called general AI, and the third one is called super AI. So the narrow AI part is where we are right now. The entire world is struggling with narrow AI. So narrow AI means we are trying to make artificially intelligent machines here, but they are going to solve only one single task. Say, for example, driverless cars. Humans can drive, you can drive. Can the machine do it? If the machine can do it, the machine is an intelligent machine. But this is narrow intelligence. The machine that can drive cannot talk to you also. Just because it is like fully capable to drive your car does not mean that it can like send emails on your behalf as well, and it can clean your house as well. You get my point here? So right now the world is dealing with narrow AI. The next phase for us would be to make such kind of robots wherein, hypothetically speaking, imagine you have a robot in front of you and you ask the robot, could you please cook biryani for me, and the machine does it for you. And then after 1 hour you ask the machine to like kind of clean your clothes, and the machine does it for you and all that. So my point is artificial intelligence is predominantly a field of research. We are still kind of writing algorithms and trying to devise new ways in which we can simulate what we call as consciousness in human terms, right? Data science, on the other hand, is more about the practical aspects of it. So for example, just to give an example, just to make sure that you understand properly, a lot of people do engineering, and a lot of people do BSc and BTech, like you see. Okay, so BSc is more about the research aspect of things. Your Bachelor of Sciences, right? But the implementational part of it is nothing but data sciences. When you implement, so BSc and BTech, the two different kind of degrees that you have. BTech is more inclined towards implementing those ideas in the industry, whereas BSc is more about the theoretical aspect. Okay, all right. So I hope now you have a very rough, broad, understanding about what AI is. Of course, over the period of time, we are going to be, kind of drilling down into these things in particular, and we are going to study in detail about these things. But today's session is supposed to be a demo session, and I'm just trying to paint a picture for you guys. I'm just trying to make you understand what AI is, how is data science and AI like, what is the similarity between them and all that. Now let's talk about data mining. I think you might have heard of data mining as well. You might have heard of machine learning as well. You might have heard of neural networks as well. So what do you think machine learning or deep learning is? What I'm trying to explain here is, see, when you see science and technology, right? You have just this might be a very bad example or a very lame example, but what I'm trying to explain is the relationship between data science and artificial intelligence. So when you talk about AI is predominantly a field of research where you are like dealing with how exactly are you, kind of going to make more and more smarter machines. Whereas data science is not about research and all that. Data science is just about getting the right answers for our current tasks. Say, for example, I want to increase the profitability of my company. I want to make some predictions. I want to do some forecasting. So all those kind of things, when you are like kind of trying to solve a particular problem, you would be implementing data science. I just gave an example of BSc and BTech. The predominant difference between the degrees of BSc and BTech is that in BSc, for example, you are more inclined towards the theoretical and research aspects of things, right? You are a Bachelor of Sciences, the entire sciences you are like dealing with. But technology or engineering is the implementational part of that science, right? So when you say computer science and engineering, you read computer science, and then engineering part of it is what? The implementational parts of it, right? So how exactly do you implement those things in the real world, right? So the same analogy can be applied to AI and data sciences as well, right? Now, so what we are going to be doing, of course, is what? Data science, right? We are going to be, say, for example, working for a company where we might have some tasks where we might have to predict something, or we might have to forecast something about the future, or n number of problems we could have. It could be about natural language processing. It could be about computer vision or object detection. But my point is, all those things that we are going to be solving, we will call them not as AI, but we'll call them data science. And the implementational part of it, once again, would be analytics. and something, and I hope I'm like making myself clear to you guys. Let's talk about data mining for a bit now. What is data mining? Can anyone take this guess, or does anyone know what is the meaning of data mining? Data mining has been there with us since a long back. Even before people knew about data sciences, there was something called data mining. So what do you think data mining? Yeah, okay. So extraction of data. Not exactly. Extract useful information. Yes, yes. I think that is a better answer. Data research, when you say, it is a very vague answer. Going deep and use the data. Yeah. So see, mining. When you say data mining, a lot of my students sometimes misunderstand the meaning of data mining. They think that kind of scraping the data and finding a lot of data is what the meaning of mining is. But no, mining is not that. Mining is not scraping data, or mining is not accumulating data, or extracting raw data that Pratham has written. It's
all
not
about
that.
finding pattern in a specific data.
Sorry?
It's all about finding a pattern in a specific data.
Yes, more suitable answers. So data mining. So mining, what exactly do you do when you are mining? So for example, if you're mining gold, what are you doing? So out of all the mud and out of all the things that you had, you are looking for something that is valuable to you. That is the meaning of mining, right? Coal mining does not mean just digging a lot of earth and getting a lot of materials from there. No, mining means within that cluster of humongous amount of data that you had, you're just trying to find for something that is useful to you, right? So that is data mining. So data mining, this word data mining has been there with us since a long back now. Even before people knew about data sciences, they used to call it data mining. But now, in the present context, in the context of studies of data science, data mining has become a very small part now, and data mining is just like exploratory data analytics that I'll show you. Right. So when you say data mining, for us now, in terms of data science, we are going to be calling it as exploratory analytics or descriptive analytics, if you have heard of these things. If not, then I'll explain. Don't worry. Right. So this is about. So okay, fine. So what about these things now? Machine learning and deep learning. Have you heard of deep learning? Have you heard of machine learning? I think machine learning would be. What do you think? Even if you do not know, can you take a guess? What do you think machine learning is? What is the difference between machine learning and deep learning? Do you know any other kind of learning apart from machine learning and deep learning? Have you heard of, say, for example, reinforcement learning and all those? So let me explain those now. Okay, so machine learning, when you talk about, once again, all these learnings, machine learning or deep learning, or say, for example, reinforcement learning, all these learnings, when you say, what exactly is the meaning of machine learning? I can drive a car. Can the machine do it? I can tell you whether if you give me an application for a credit card, just by looking at your application, your name, your salary, the city that you are living in, the number of dependents that you have, your CIBIL score, the number of pre-existing loans that you have, the company that you are working for, and all those things. Just by getting that information, I can tell you whether your credit card application should be approved or rejected. But can the machine do it for you? So this is basically what the meaning of learning is. So our entire goal here in machine learning or deep learning or reinforcement learning is to make the machines learn how to do things and then perform those tasks themselves. Right. So for example, now some example problems there would be. I'll be giving you some examples to explain what is the meaning of machine learning and deep learning also. The basic difference between machine learning and deep learning. Please listen to me very carefully. The difference between machine learning and deep learning. Let's talk about that now. So machine learning predominantly deals with mathematics and statistics. The entire algorithms, all the things that you can do in machine learning has a basis in mathematics and statistics. What do you think is the field of data science? Data science talks about biology or physics or chemistry. What do you think? You getting my point, right? So this entire thing is a field of math and stats, and machine learning tends to solve problems. It tends to, kind of teach the machines by using data, by using the concepts of mathematics and statistics. All right. On the other hand, when you talk about deep learning, so there are certain differences between these things and deep learning. So deep learning predominantly is an imitation of human biology. What I mean by that is, uh, let's forget about all the computers and programming languages and everything. Let's forget about everything for a minute. Let's talk about individual person. Okay, every one of us. How are we making decisions? How are we thinking? How are our memories working? And how are we able to make analytical decisions? Which system of the body do you think is responsible for these things? Do you think it is the digestive system that is enabling my memory? Do you think it is my respiratory system? Do you think is it the reproductive? What kind of system do you think it is that is kind of handling all my um, um, you know analysis that I'm doing as a person? So it is nothing but the nervous system, right? If you have heard of nervous system, so nervous system is the one that is responsible for all our stimulus and everything. Yeah, sir, nervous system. So the smallest unit of nervous system is nothing but a neuron. A neuron is nothing but the smallest unit of the nervous system. In each and every one of us, we have nervous system, and all of our nervous system is built up from billions and billions of neurons interconnected with each other. So in humans, what we have is we have neural networks. We have neural networks in our human body, and that neural network gives us the ability to, say for example, look in front of us and identify a lot of things. That, okay, fine, this is a truck, this is a car, this is a road, this is a barrier, and these are people, these are cyclists, these are motor cars, and all those. Can the machine do it for you? So we know for a fact that our nervous system, based upon these billions and billions of neurons, our nervous system is able to give us this ability of vision. We can identify objects. We can respond accordingly. Neural networks also gives us the ability of natural language. What is the meaning of natural language? Right now, what we are discussing, this is what natural language. This is not a programming language. This is natural language. Machine only understands programming language. It does not understand natural language. For example, I'm like looking at my computer screen right now, and I'm, say for example, saying something. Do you think the machine understands? If I just speak to the machine, add 2 plus 3, do you think it can do it for me? So machine only understands programming languages. If the machine could also understand what we were speaking as natural language, right now we are speaking English. This discussion could also have been in Hindi or Spanish, provided that all of us were able to understand the same language. We could have chosen any language for our purposes, right? So my point is, we have seen that the human biology is like well capable enough to provide the ability of natural language, to provide the ability of, say for example, vision, object detection, and so on and so forth. So deep learning we just have, what we have done is we have created artificial neural networks. So the same thing that machine learning can do on the basis of math and stats, deep learning can also do it, but it will take help of artificially created neural networks. So in that case, when say for example, if you are working on deep learning problems, we will be writing programs to create artificial neurons, and there will be a lot of neurons. All these neurons will be connected together, and that will create an artificial neural network for us. And further down the line, as say for example, if I get an opportunity to teach you guys, I'll show to you how very small neural networks can very nicely identify images. You provide an image, and that neural network will tell you that this there is a car in this image, or this number is written on the number plate, or something like that. Handwriting recognition, object detection, prediction, forecasting, whatever you think of, it can be done by the help of deep learning as well. And deep learning makes what? It makes artificial neural networks. Machine learning also does that, but it takes help of completely math and stats, nothing else. And then there is third kind of learning as well, if you have heard of it. The third kind of learning is called reinforcement learning. So reinforcement learning is even different from machine learning and neural networks, or deep learning. In fact, reinforcement learning is for example, say for example, if you have to make a robot, and if you have to teach this particular robot to walk, you have a robotic dog. You have a robotic dog, and you want this robotic dog to walk. Now, this particular problem cannot be solved with machine learning or deep learning. In fact, These kind of problems are what we call as learning by experience, cue learning techniques. So what happens is, take an example of a small child, an infant that is just born. This particular infant does not know how, what things are or how to respond or whatnot. But the small kid, say for example, the small kid was playing around and there was a utensil lying around, and this kid goes and touches that utensil because he does not know what will happen. He was not provided any data. There was no adult that was telling this guy not to. There was no adult to tell this small kid that you should not go and touch the electrical wire or these utensils which are kept there. So, say for example, this small child very innocently this goes and touches that utensil. That utensil is very hot. Okay, so this guy goes and touches with the slight of his finger, and this guy suddenly realizes that no, what I got in return is not something that I want. My hands are burned. I don't want this to happen. This is not a very good feeling. So from the next time, what will happen is this kid will have in mind that if I do this, if I perform this particular action, whether I will be getting a reward or whether I will be getting a penalty. So over the period of time, the more time you provide, the more exposure you give, the more experience it obtains, the better and better decisions it will be able to take. So once again, coming back to the example of robotic dog, if say for example we have a robotic dog with 4 legs and we want that particular robotic dog to walk, do you think it is easy for us to specify that अगर आपका आगे वाला पैर इधर है और पीछे वाला पैर इधर है और दोनों पैर ऐसे हैं और अगर inclination इतना है तब इतने एंगल से इतने स्पीड से, I mean it is not possible for us to kind of specify during which scenario, where exactly are your legs currently placed and how to move forward. I mean, can you actually write those statements in a program? Can you give instructions to the machine by writing if else statements? No. There is no way in which we can write all those scenarios. Right now, the dog, say for example, the legs of the dog are in this particular position. After one step, the position will change. The ground might also change. Whether there might be an obstacle in front, there might be an inclination or decline in the rasta there. So there can be n number of things, right? So reinforcement learning actually is learning by experience, where we what we do is we try to expose our program to n number of scenarios. And based upon those scenarios, based upon the results, whether it was a good thing or a bad thing, based upon that, the machine learns for itself and it builds. So 3 types of learnings we have discussed: machine learning, deep learning, and reinforcement learning. Okay, now. So let's move forward now. I hope these kind of terminologies are now clear. So when you say data science, what we are going to be doing in real world is data science. Data science can be done either by using machine learning or by using deep learning. You get my point? So whatever we have to do, whatever we have to achieve as our analytics task, as our data science project, we can perform this particular project, data science project, either by using machine learning or by using deep learning. From teaching perspective or from your perspective as a student, it actually makes sense to first understand what machine learning is and then learn what deep learning is, because a lot of concepts that are used in deep learning have been taken from machine learning itself. So something along those lines. Anyways, moving forward. So yeah, let's talk about analytics now. The implementation of data science. Analytics. Let's talk about analytics. So broadly, there are 4 different types of analytics. There are 4 different types of analytics that I'm going to explain to you now. The first kind of analytics that we can do is called exploratory analytics. All right. The first kind of analytics that we can do is called exploratory analytics. In the past, people used to call exploratory analytics as data mining. I hope you understand now. So data mining for us has been now limited to only एक छोटा सा part बन के रह गया है, which we call it as exploratory analytics. So exploring something. What is the meaning of? Okay, I have a question from Dhanesh. How to make it, sir? What exactly are you asking, Dhanesh? Make what? Are you talking about those robotic machines that I was talking about? Reinforcement learning, are you asking? Yeah, how to make what? This is what I want to understand. Okay, ठीक है. You write in the chat box. By that time, I'll continue discussion forward. Yeah. So I was talking about exploratory analytics. So I want to understand from you, what is the meaning of exploring things? For example, if I ask Sajid कि साजिद क्या कर रहे हैं, साजिद ने कहा कि मैं एक्सप्लोर कर रहा हूँ, आई एम एक्सप्लोरिंग थिंग्स. व्हाट इज द मीनिंग ऑफ दैट? So exploring things means that you are not looking for anything in particular. You're just browsing things. आपको नहीं पता कि what you are looking for. You do not have a target set in mind. You have something with you and you are just looking through it, trying to see if there is something that can come out just by looking at it, right? You did not have any end goal in mind. Okay. So I just gave you some data. Say for example, if I'm working in a company in HR department, okay, and HR department gives you the details of all the employees that are presently working in the company. So exploratory analytics, if you're performing, what kind of things would you try to do if you are doing exploratory analytics? You would try to see, for example, if just by looking at the data, I can make an assumption na, कि my workforce is a young workforce, or I have older people working in my workforce, or are they like average? You get my point. If I have an employee database, I must be having age column also. Just by using that age column, can I not find the average age of all my employees? Can I not decide for myself whether my workforce that I have in my company is a young workforce, or just by looking at the salary, can I not decipher for myself that how much money that I am spending, my company is spending just for giving salaries and all that? How many people are presently working in lower designations? How many people have what kind of skills? So I did not have any particular end goal in mind. I just wanted to explore what things can come up, what interesting insights can come up. What is the what is the age of retirement for all these people? Up to what age are these people, kind of by themselves, they are like going out of my company, they're leaving my company. Attrition, this word attrition. A lot of HR people are like very much concerned about studying attrition. Why people are leaving our company and going to different company? Why say for example, Dhanesh is not using Airtel SIM and he is going to Vodafone. You get my point. So attrition is your customers leaving you for someone else. That is the meaning of attrition. So a lot of studies can be done just by exploring the data. So that kind of things would be covered under exploratory analytics. I have a question. Are you interested in Python? Are you asking me this? Shubham, I should be asking you this question because I am the one who is, kind of going to teach you Python. So if you are interested in Python, come to me. So anyways, I'll talk about Python as well, and how data science and Python would kind of be together, because all the discussion that I have had, I've told you what data science is, even though you do not know the nitty-gritty features of it, but at least I hope you understand that data science is nothing but a field of math and stats. So you can ask me then how come Python is into the picture? So I'll tell you, just give me a few more slides and I'll reach that discussion, and we'll discuss about Python then, how Python is associated with these kind of things. All right. Okay. Moving on to the second type of analytics. Okay. That is nothing but diagnostic analytics. Achha, one more thing, guys. There is no specific ordering that after exploratory comes diagnostic, after diagnostic comes predictive. Nothing like that. Please do not think that there is any ordering in between these things. It is just about your problem statement. You might be exploring, you might be doing diagnostic analytics, you might be doing predictive analytics, you might be doing prescriptive analytics. All right. So there's no ordering to all those things. So anyways, let me explain. Before I explain diagnostic analytics, let me explain what is the meaning of predictive analytics first. So to be able to make predictions, what will happen? So say for example, India ने इतना रन बनाया है, बारिश हो रही है, पिच ऐसा है, ये है, वो है. So can you predict based upon this particular situation? Can you predict what is going to be the outcome of this particular event? If I give you a blood sample, okay, if I give you 1 drop of blood sample, by looking at the condition of that blood sample, by doing some tests on it, can you tell me whether I have malaria or tuberculosis or cholera? If I give you my credit card application, if I tell you what my salary is, what say for example, what is the number of dependents, what is my CIBIL score and all that, can you predict whether my application will be rejected or accepted? If I tell you that there is a house located in this particular locality with proximity to this school and this park and this metro station, and if I tell you that this particular house is this much square feet, if I tell you this house is located on the 2nd floor, if I tell you that this house is 10 years old. This building is 10 years old. By looking at those scenarios, can you predict the price of that building? So I hope I'm trying to portray to you what I'm trying to explain to you. What kind of problems can you solve by doing predictive analytics? Okay. So this was my agenda. So say for example, so prediction is different from forecasting. So predictive analytics means that you train the machine that look, this is how it happens. These kind of people were there with this salary, this age, this company, this number of dependent, this civil score, and we had accepted or rejected their application. So you give the data to the machine. You do not give instructions. You do not tell the machine to approve or reject if the age is more than this and all that. No instructions. We just give the machine some data. And based upon that particular data, the machine tries to understand the behavior. How exactly are things behaving? And based upon that, it tries to give you the answer that if this is the current situation, the house or the price would be this, or the blood test would lead to malaria or something like that. You get my point now. So this was the second example, predictive analytics. Now let's talk about diagnostic analytics. So diagnostic analytics actually deals with finding, pinpointing where exactly the problem is originating from. So say for example, Pratham comes to me and Pratham asks me that, Tushar, I have this company and I'm spending this much money. I have these many employees. This is my working hours, and this is how much I'm spending on research. This is how much I'm spending on marketing, and this is how much I'm spending on employee salaries and everything. This is the country that I'm working in. This is the list of regulations that I'm operating in. Can you tell me why I am not able to get my profits? If say for example, this is the question. So this kind of question is an example of diagnostic analytics. So when do you go to a doctor? Kab hota hai diagnosis? When do you think your diagnosis takes place? When you go to the doctor, what happens? The doctor diagnoses. The doctor diagnoses सबसे पहले. They ask you, यहाँ खांसी हो रही है, हाथ उठाइए, ऐसे कीजिए, वैसे कीजिए, ये था, वो था. So they ask you a lot of questions, and based upon that, they diagnose. That means that they tell you that आपके सर में जो दर्द हो रहा है वो आपके हाथ में चोट लगने might be a stupid example, but I hope you understand the meaning of diagnostic analytics. So finding the root cause of a problem, because identifying a problem is very important. And once you have performed diagnosis, then what comes next? Prescriptions. So once again, when you go to a doctor, what the doctors do? They diagnose. They tell you this is what is wrong. And at the same time, they also tell you that if you have to rectify this, you have to, kind of ये वाला drop आपको 2 बार लेना है, ये वाली दवाई 2 बार खानी है आपको, and this is how you have to proceed forward, right? So diagnostic and prescriptive, diagnosis and prescription. Diagnosis is finding the problem, the root cause analysis, RCA, if you have heard of. And if say for example, at the same time, if I am able to, tell Pratham that Pratham, this is the problem, this is why you are not able to, generate profits. Now Pratham will tell me, okay, fine, I want 5 lakh rupees per month as profit. Tell me how can I do that? So now a data scientist will write prescription that you should increase your number of employees from itna to itna. You should increase your spending on R&D. You should increase or you should reduce your budget on marketing, something like that. You get my point? So those kind of things would be, counted as, those kind of problems would be categorized as prescriptive analytics problems. Okay. Now, 4 different types of analytics. The good news is you do not have to learn 4 different things for 4 different problems, right? You do not have to learn 4 different things. All you have to understand is you just have to understand how machine learning works. Any kind of problem, exploratory, diagnostic, predictive, or prescriptive, any kind of problems would be solved by using those algorithms that we would be learning in machine learning or deep learning, or say for example, not reinforcement learning, because reinforcement learning may the problem statement itself is different. So either machine learning or deep learning, anything you can use, but you do not have to learn 4 different things for these 4 different analytics types, is what I'm trying to explain. All right. Moving further. So I was talking about smarter machines, right? So there could be you can make the machines learn either by the machine learning technique or by deep learning technique. So machine learning is nothing but learning from data itself by using the mathematical and statistical tools. And deep learning, on the other hand, once again, is learning from data itself. Don't think that deep learning there is no data, because this is data science. No data, no science. Data science is an art of making data-driven decisions. If you do not have data, there is nothing you can do about it. So my point is, machine learning and deep learning both will take from you what? They will take from you data, and then they will give you output. But machine learning will upon that data, machine learning will apply statistical approaches. Deep learning will apply neuroscience approaches, right? So machine learning, deep learning. So machine learning, this is very important slide now. Please look at this very carefully, because if at all, out of all these participants who are here with me today, if at all you are interested in learning machine learning, this is what you will be learning. So say, for example, if you are trying to understand what is the meaning of machine learning, and if you want to, learn how to do this. So in that case, you will be learning these things only, supervised and unsupervised. That is why I'm asking you to kindly pay attention to this particular slide, and understand what all things are present there in machine learning. All right. So we have so within machine learning, there are two different broad categories in which machine learning can be done. It can be done either by supervised learning or by unsupervised learning. Supervised learning means there is some supervisor. There is someone who is monitoring what machine is learning. Is the machine learning good things? Is the machine learning wrong answers? So what the machine is learning, if there is some kind of supervision that is present, those kind of problems would be called supervised learning. On the other hand, if there is no supervisor, if there is no one to tell the machine what the machine is doing or what the machine is learning from the data is right or wrong, in those scenarios, it would be called as unsupervised learning. So I'll give you some examples also. You will understand by examples what kind of examples would fall into supervised learning and what kind of examples would fall into unsupervised learning. So supervised learning is nothing but either these two tasks. Either you are going to do regression or you are going to do classification. So what is the meaning of regression and classification? So let me explain to you classification first, and then I will come back to regression. Okay. So classification tasks are predominantly those kind of tasks where the answers that you are looking for is in categories. So for example, if you are trying to predict, once again, I'll repeat, if you are trying to predict if my credit card application will be approved or rejected, or if you are trying to predict that if, say, for example, my height is this, my weight is this, my body mass index is this, so can you predict what kind of t-shirt size will I be wearing? Will it be a small t-shirt or a medium t-shirt or a large t-shirt? Are you getting my point? I'm not talking about numbers. I'm only talking about categories. What disease you have? Do you have malaria or you have tuberculosis? So these kind of categories, if you are interested in finding, if you're interested in finding these kind of categories, then classification modeling is the way for you. So classification modeling is what? It basically gives you categorical answers. Yes, no, true, false, accepted, rejected, small, medium, large. So these are all categorical values. I'm not saying, I'm simply saying t-shirt size should be small. I'm not saying 39 centimeters or 40 centimeters. No numbers. I'm not asking whether this person has 70% stage of cancer or something. I'm not asking. I'm just asking, tell me whether this person has cancer or not. Yes or no, just tell me. I'm not asking you to give me, yes, there is 30% chance of cancer and all that. Just answer me yes or no. So if these kind of problems are what you are dealing with, classification is what you will use. But on the other hand, if you are not interested in categories, if you are interested in actual numbers, if you do not want to know small, medium, large, if you want to know 42.5 centimeter, or if you actually want to know what is the probability that this person will be having cancer. So instead of me answering yes and no, you want me to answer as 0.7 or 0.8 or 0.9 or 0.4, things like that. If you want to predict the price of a house, so that price is not categorical. I'm not asking you to tell me whether the price of the house is high price or low price or medium price. I'm asking you to tell me how many lakhs will I have to pay for this particular house. So these kind of examples would fall into the examples of regression modeling. I think Sajid had answered to me when I was asking about prices. Sajid had written very nicely that it is by using regression. I will not say linear regression, Sajid. I'll explain to you why you cannot say linear now without even looking at data. But yes, regression is what you would be doing, right? So supervised learning is somewhere around these lines. So you have regression modeling and classification modeling. Regression modeling में all you are interested in is actually at looking at the final numbers, whereas in classification modeling you are not interested in the numbers, but rather you are interested in looking at the categories themselves, not the numbers, in categories. So this is basically about supervised learning, regression modeling and classification modeling. And now let us move towards the second type, that is nothing but unsupervised learning. So unsupervised learning has only one type of modeling, that is clustering. Just like in supervised learning you had regression and classification both, in unsupervised learning there is only one thing called clustering. Now I'll give you one example of clustering also. How is it different from unsupervised learning? I think a lot of us must be using social media. Social media, where I say you must be using Instagram or Facebook or LinkedIn or whatever. I hope you get my point. In all these platforms, have you seen this section where they suggest you friends, people you might know, or friend suggestions or something like that? How do you think that is happening? Do you think Mark Zuckerberg has this data that Sajid knows these guys, Aditya knows these guys? That is why Pratham should also know these guys. Do you think there is some kind of data that actually exists? No. There is no supervision. There is no way in which you can provide a data that can supervise the machine to tell you that if I have to suggest some friends for Sajid, these are the name of the friends that I have to suggest. There is no way in which I can find it out. So what exactly will be done there? So in unsupervised learning, in clustering problems, they are rule-based problems. So instead of us looking at prior data, looking at, for example, in supervised learning, what we were doing, we were looking at patients who already had malaria, and by looking at their behavior, we were telling that now if you give me one blood drop, now I'll tell you whether malaria is present or not. So in those scenarios, we were giving such kind of data to the machine. But in unsupervised learning, for example, friend suggestion wala problem, there is no way in which you can tell the machine that these are the people and these are their friends. And that is why if Tushar knows ABC, then Pratham also must know ABC. This is not how you will be solving these kind of problems. I hope you understand. So what you will do is you will make use of some rule-based techniques. You will do some clustering, what you will do is you will try to find out whether, say for example, if Aditya and Pratham are there, if these two guys are from the same city, do you think there are chances that they might know each other? Yes, there are certain chances. Say for example, there are three people, Pratham and Aditya are from Gurgaon, and say for example Tushar is from Bangalore. So who do you think has, out of these three people, the two of them, who do you think has better chances of knowing each other? People who are from the same city. I'm not saying they must be knowing each other. I'm just speculating. Who do you think would be knowing each other? The friend suggestions that you also get. Not a lot of people are actually familiar to you, right? But still they are in a suggestion. So how does it happen? Now say for example, Aditya and Pratham are from the same city. Additionally, in the second column, so I have their city of residence. So Aditya also has written Gurgaon and Pratham also has written Gurgaon. Now the second column is there. The second column is year of graduation. Okay. Oh, no, wait. The second column, say for example, is the college that you have studied. So Pratham and Aditya, I told you, both were from the same city. And now I'm telling you that we know that these two guys are from the same college also. Do you think now they have more chances of knowing each other? What if I tell you, now say for example, additionally I tell you that they are from the same city, they are from the same college, and now if I tell you that their year of graduation is also same, both of them have graduated from the same city, same college, same year. So now do you think their chances of knowing each other has increased? If I tell you that their department of fine, they graduated in the same year from the same college, but their department was also same. Now do you think they have even more chances of knowing each other? So unsupervised learning actually works in this particular way, and this is how your friend suggestions also are generated, rather than the machine doing any kind of predictive analytics for that particular matter. I hope this is clear now. Okay, so this is about machine learning, supervised and unsupervised learning. Okay, so moving forward now, Yeah, so I told you about deep learning also. Deep learning is nothing but the, now that we have so much technological advancement that we can actually understand how our human brain works. So we are just trying to imitate the neural network in the human brain. We just try to simulate that by using artificial neural network. To do that, we would be making use of languages like Python or something like that. Okay. So the same way you have artificial neural network, convolutional neural networks, and so on and so forth. Moving forward, let's come to this now. Let's talk about this, and then I'll give you a 5 minutes break. So I told you that we have to perform data science. Okay. What is the meaning of a tool? What does a tool do for you? Please answer this. I need answers from you. What do you think the task of a tool is? Where do you need a tool? How many of you have seen Three Idiots? Or have you read the book 5 Point Someone?
Tools helps us to make the implementation of our machine learning programs.
Why would you say machine learning program? Can't you keep your answer to a generic level? Fine, okay. So tool is something that can help me, perform a task or a certain activity. Yes, to minimize our work, to remove the unnecessary details, abstraction, if you have heard of, right? So say for example, we are all sitting in Connaught Place. Okay, Connaught Place is a place in Delhi. Say for example, we're all sitting there, and if I ask you to stand up and walk towards, say for example, the Statesman building. If I ask you to do this, it's very easy for you, right? You will simply get up and you will walk to Statesman building. Okay. Let's make this problem a little more difficult. Now we are all sitting in Connaught Place, and if I ask you to go to Noida, okay, you can still walk, can't you? You can still walk. Now let's complicate this problem even further. We are all sitting in Connaught Place, and if I ask you to stand up and go to Agra, okay, theoretically speaking, it can still be done. I can stand up and I can walk to Agra. Fine. If I have to do this, I can do it. The problem is there are a lot of things that can happen while I'm going to Agra. I might die of heat stroke. Some other car might come and hit me or something like that. Or it might take me so much time that by the time I reach Agra, I would not even kind of need to solve that problem also. So in those scenarios where things start becoming difficult, we make use of tools. Now there are different tools. To go to Agra from Connaught Place, I have a tool called helicopter. I can fly from Connaught Place to Agra. I have a different tool. It might be in the form of, say, for example, a Land Rover, a car I have. I can still drive from Connaught Place to. That is a tool for me, right? It is making my things easier. It is making my task easier. I could also make use of a scooter. So all these three tools are essentially helping me do the same thing. But all these three tools, if you think about them, all these three tools have their own advantages, disadvantages. Helicopter is very expensive, but very fast. Additionally, अगर आपको बीच में रुक करके चाय पीने का मन करेगा, तो you cannot ask the helicopter to kind of land somewhere and ask for a cup of tea from a local vendor. You cannot do a lot of things when you are in a helicopter. You get my point? At the same time, if you are in a car, it might be a little less costly, might take a little more time. If you go by a scooter or something, you get my point now. So there are multiple tools. So let's come back with this example in mind. Let's come back to our discussion about data science. So I told you data science is predominantly a field of maths and stats. So can't I do? You think Tushar Anand cannot perform maths and stats by using pen and paper? You think Shubham or anyone for that matter? You think you cannot do any statistical computation by using pen and paper? But you don't want to do it on your pen and paper. I know you can find standard deviation. I know you can implement the algorithms, but you do not want to do it by hand. A simple division, if you have to do, you tell me up to what decimal point will you divide? Up to what accuracy will you maintain? And how much computation will you do? Even if you make one single mistake by hand. So my point is, for data science tasks also, we need some kind of tools that can do those things for us. So there are multiple tools in the market. If you have heard of SAS, if you have heard of R, if you've heard of Python. So a lot of people, do the same things that we were discussing in data science by using SAS. Some of them do it by using R. Some of them use Python. So these are tools that are going to make your task easy. From now on, you do not need to understand how the wiring is done in your fan. You just have to switch on a button and the fan will turn on. You do not have to go into the nitty gritty features. What was the positive wire, negative wire, carbon brushes, electromagnets moving in opposite directions, and all that. Not our problem anymore. Abstraction we have achieved by using a tool. We have a switchboard. If I simply press that button, that will simply do everything in the background. I do not have to worry about it. This is what my tool is doing for me, right? So our tool, in my opinion, you can actually go for SaaS also. SaaS is a very, very expensive tool, and by click of very small buttons, and by writing very small code snippets, there are a lot of things that you can do. The final output will be so nicely presented in form of PDF and whatnot and everything. So SaaS is one tool, but the okay, yeah. So, but the problem with SaaS is that SaaS is so expensive that not a lot of companies in real world, unless you are working for companies like JP Morgan Chase or AIG or Goldman Sachs, from where you can expect कि इतना तो पैसा होगा उस company के पास, they can buy so many licenses for so many developers. Say for example, if a data science in a company called JP Morgan has 50 members in a data science team, so JP Morgan Chase would be required to purchase 50 licenses for 50 developers, right? Not a lot of companies have that much money. Startups mein to you can simply forget. You will, if your agenda is to kind of start working for startup companies, I don't think SaaS is something that you will ever encounter, because they will not have that much funding to spend so much money on software like that. Where at the same time R and Python can do it for free. R is free, Python is free. So this is something, but now once again you will ask me, then why are these companies also paying this much money? Just because they have money, they are spending, they're wasting their money. So no, it's not about that. These companies also have teams that are working on R, Python, but the biggest advantage they have with SaaS is that SaaS once again is a very big company, a privately owned company, just because of which its product SaaS is a very expensive one. So the point is, say for example, if I am Goldman Sachs and I have a team of 50 developers who are working on SaaS, okay, the good news for me is if something goes wrong, I can sue this company. I can file an FIR against these people, SaaS company, because of their tool. I was not able to get optimal profits and all that. So every time there is a dedicated customer support, there is people who can solve your problems for you in minimal amount of time. So those kind of advantages you also get from a company like SaaS, because their software is so they're providing those services to you. So those companies, they are like ready to pay that much money just for some kind of support in return. On the other hand, if these companies were working on Python, who do you think they would blame? If Python libraries are wrong, or say for example, if R libraries that you have written is not giving you optimal results, it might be because of some coding issue or something. So who will you blame? If say for example, if your calculation is is differing by even by 0.1% out of millions of dollars, how much do you think 0.1% is? Do you think it is really insignificant amount of money? So my point is, yeah, can blame ourselves only. Okay, fine. My point is, I'm just trying to portray the arguments of using some tool and not using some tool. I'm just trying to portray that. So on the other hand, you have things like R and Python. So they're both free. They're both languages. R has been present in the field of data science since a really long while now. And I want to explain something about Python as well. So see, Python has got nothing to do with data science. Python is just a general purpose programming language. SaaS is a dedicated tool. R is a dedicated tool for data science. Python was not. Python was just a programming language that people were like working on. The good news with Python suddenly was that a lot of open source community, a lot of developers started working with Python. Just like a lot of developers have started working with Android. They're not developing apps for Bada OS. They're not developing apps for, say for example, Symbian OS. But a lot of developers are developing a lot of applications for Android. That is why you also have so many applications. Do you think if the developers were not present with Android, how would you even get those games, and how do you think would even WhatsApp be possible? It is only because of the developers that Android is famous. It is not famous because of users like us. If you think Android is famous because of us users, you are wrong. It is famous because of developers, because there are a lot of developers that are developing 75 different types of applications for whatever you can think of. The same example, the same analogy is applicable to Python also. So Python, just like, say for example, if I purchase a phone, if I purchase say for example a OnePlus phone, if I take it out of the box, that particular phone, just you take that box out of the phone, you just unbox that phone, that brand new set will not be able to do a lot of things. For example, it will not be able to book flight tickets for you. It will not be able to send WhatsApp messages. It will not be able to give you Zomato reviews. So what do? In order to extend the functionality of your phone, what do? You go to Play Store and you install some additional programs, and now your phone has enhanced capabilities. Now your phone can identify the stars in the sky also. It can book tables for you also in restaurants. It can book flight tickets, movie tickets, and whatever you want to do, transfer money and whatnot. The original phone that you just took out of the box could not do it for you, right? The same is applicable with Python also. There are so many developers, and these developers have created so many libraries. So in Python, we are not going to call them as apps. Just like you have apps for your phones, we have libraries for Python. Okay, so a lot of developers have written such nice libraries for Python that now Python is able to do a lot of things that other programming languages, that better programming languages like C, C++, Java cannot do. C, C++, Java are better languages because of their programming efficiency and all that. But even they cannot perform a lot of tasks that Python can do. For example, how many of you have in the past, at some point of time, tried to download YouTube videos? How many of you have ever felt like I should download this particular video? So you might have used, say for example, what? Internet Download Manager, YouTube Downloader, these kind of applications you might have used. I'm telling you one thing, I'm not exaggerating. Okay, there are 3 lines in Python using which you can download any video from YouTube. Three lines of code. I can show it to you right now if you want. So Python can do automation testing. Python can send mails for you. Okay, you do not have to go to Gmail. From your Gmail account only, by using Python itself, you can send emails. Python can connect to relational databases. Python can do n number of things, is what I'm trying to say. The original task of front end and back end development for websites is, of course, is the primary task that Ruby on Rails and Python, all those things are doing. So in the same way, a lot of mathematicians and statisticians have adopted this language of Python, and they have developed so many nice algorithms, and they have developed so many nice libraries that can do data science for us as well. So now Python is in a position to actually help us solve our data science requirements also. And as it so happens, Python is one of the most popular tools right now. In fact, the popularity of R is like continuously declining every day. Every other person is trying to move towards Python. Every company is moving their implementation or their teams towards Python. So things like that. So Python is a very good choice for you to start learning how exactly to implement data science or whatever. And the good news is Python is so easy, such an easy language that even people who are like completely non-technical people, I have had students who are like book authors, completely non-technical people. So Python is so easy to understand that it is very easy for even non-technical people to get onboarded, to start learning Python, to start programming, things like that. So the tool for us is going to be Python, right? Yeah.